we've got a ferromagnetic material, such as iron here, an iron cylinder basically. And it's connected to a cylinder that's wrapped with a coil. And an interesting thing will happen with the ring depending on what kind of source it's hooked up to. So it could be hooked up to DC or AC. Alright, so we want to try to predict what will happen based on everything we've looked at so far. Like, what does the ring do? Does it just remain motionless if it's connected to DC? Will it go up and then levitate almost magically? Or will it just bounce, like go up and then come back down once the switch has been closed here? So you can make your prediction and then I'll explain. Alright, so closing the switch will cause current to build up in the coil, but slowly, because it's a coil. And so as the current builds up, go in this direction. According to the right-hand rule, if you just grab that with your hand, the fingers would coil around this way, and the thumb would point in the direction of current, but the fingers would tell you that there would be a magnetic field created that'll go all throughout the iron. Okay, the iron just helps direct it. Alright, so we would have this. Now, as that B field builds up, there's going to be an induced eddy current in the ring. Because see, the ring doesn't like the flux through itself changing, and it's going to try to induce a current to stop that from happening. The field that it needs to induce has to oppose the increasing B field, see? And so it'll create a current of its own. According to right-hand rule, though, let's see, it would need a current which points this way. Basically clockwise, looking from the top down. But this is DC current, right? So once the current in the coil builds up to its maximum level, then what will happen is you'll reach a state where the B field is just constant and the flux through the ring won't be changing anymore once it reaches B max. And so if you guessed choice C, then you're correct. So why would it bounce up and down like that though? Because the ring is going to create a north of its own. Its north would be down here and its south would be up there according to the induced field that it created. But the north is going to be pushed, like repelled by the B field, so it'll jump up. If you want to quickly see what would happen with AC, let me bring up that picture. And with AC, the direction of the pipe magnetic field keeps switching. And so what happens in this case is B. The ring will go up and it can reach an equilibrium between the gravitational and magnetic forces. It actually ends up being suspended just above the metal